Okay, now let's proceed to see the demonstration of ordinal logistic regression with a given data set, So the data set is here with the SPSS software. Here is the ID, the lower's weight, the age, and number of variables are listed here. So we are interested to see the outcome variable coded as the birth weight categorical, which is 0, greater than 3.5 kilogram, 1 in between 3 and 3.5 kilogram, 2 in between 2.5 and 3 kilogram, and 3 as less than 2.5 kilogram. So we are going to predict the probability of being in category 3 versus the probability of being in category 0, 1, and 2. Or the probability of being in category 0 versus the probability of being in category 1, 2, and 3. Or we may even compare the probability of being in category 0 and 1 versus the probability of being in category 2 and 3. So this is a way how we are going to just compare the group membership or the probability of group membership of an individual in either of the ordinal categories of the outcome variable. So the predictors that we are going to use are premature labor history, coded as yes and no, 0 and 1. And then the weight of the mother at the last menstrual period as the continuous variable, and smoking during pregnancy, smokers and non-smokers, 0 and 1. So with these three predictor variables that we are going to fit this ordinal logistic regression, So as usual, click on Analyze and go to Regression, and then choose Ordinal. Choose Ordinal. And here we need to just take the outcome variable, which is categorical and ordinal, over the dependent variable. And we need to take the categorical type of predictor variables in the factors box, both the premature labor history and the smoking during pregnancy. And the continuous type of variable, weight of the mother at the last menstrual period, should be placed in the covariate box because it is a continuous type of outcome variable, So in the options box, we are not going to do anything, but in the outputs box, we are going to select these parameter estimates and test of parallel lines, test of parallel lines, in order to just get the output of whether the assumption of proportional odds has been fulfilled or not. So click on continue and then finally OK. So here's a warning, as I have said before in the theoretical session of the course or ordinal logistic regression. This is because SPSS will consider continuous variables as a categorical. So there will be 0 cells or small number of cases in those listed scores of continuous variables which were considered as categorical. So we should not bother for that. And this table will tell us about the case processing summary, the category of the outcome variable, and the categories of the predictor variables with each categories, and the number of observation and the percentage within each category. And then the next one is, the model fitting information, which compares the full model, the model with all the predictor variables, with the null model or the intercept only model. That is the model without the predictor variables. So the null hypothesis says that the two models, the full and the null models, are the same. That means all the beta coefficients in the full model are 0. The null hypothesis says. But the alternative one says the final model is different from the null model. Or that means all the beta coefficients for all the predictor variables in the final model are different from 0. So in order to say that the final model or the full model is statistically significant, the p-value should be less than 0.05 to reject the null hypothesis. So here, the p-value is less than 0.01, sorry. So we can say that the final model is statistically significantly different from the null model. And the next one is goodness of fit of the model, which tells us whether the model well fitted our data or not. So the null hypothesis again here says that the model is well fitted, and the alternative says the model is not well fitted. So for us, what we want is the model to be well fitted. So we need to accept the null hypothesis. So therefore, to accept the null hypothesis, the p-value should be greater than 0.05. Especially we need to look over there in the deviance. But in the case of Pearson, it is also greater than 0.05, but it is recommended to use, if possible, both of them, but if it is recommended to use the deviance. So the p-value for the deviance is greater than 0.05, which is 0.43. So which indicates that the model is well fitted with our data. Okay, the next thing that we are going to see is the parameter estimates, the parameter estimates. Here, the threshold is talking about the cutoff level in STATA, or the cut points or thresholds. That means simply the intercepts, We are not interested to interpret the results of these intercepts in writing the research results, but to understand what does that mean. For example, the first one stands for the probability of being in category 0 versus the probability of being in category 1, 2, and 3. And the second one is referring to the probability of being in category 0 and 1 versus the probability of being in category 2 and 3. And the last one is the probability of being in category 0, 1, and 2 versus the probability of being in category 3. The last category, the third, will not have a beta coefficient associated with it because the cumulative effect or the accumulation or the summation of the probability of each categories until the last category will be finally 1 or 100. That is why the third category beta coefficient or estimate is omitted here. So this is the way how we need to understand the thresholds or the cut points or the intercepts. What does that mean? Okay, now we are interested to interpret there in the location, what it says in the location. That means the statistical significance of the weight of the mother on the group membership of the the birth weight of the baby is having a negative beta coefficient with a statistical significant p-value, So it means that with a unit increase in the weight of the mother, the probability of getting a low birth weight baby compared to the higher birth weight baby groups. That means the probability of being in category 3 versus the probability of being in category 0, 1, and 2 decreases by 0.011 because this is negative. The beta coefficient is negative. And here, the smoking and the premature labor history, SPSS will make the category of the predictor variables with the highest frequency as a default reference group, So we will not be in a position to choose which category should be the reference with the procedures that we follow. Okay, so in this case, smokers coded as 1 are reference groups. So compared to smokers, non-smokers have a less probability of getting low birth weight baby, because the beta coefficient is negative. So compared to non-smokers, compared to smokers, smokers are 0.612 times less likely to have a low birth weight baby compared to the heavier birth weight baby groups because the beta coefficient is negative. That means being a non-smoker will just decrease the risk of getting low birth weight baby. That is it. And the beta coefficient is, the p-value is less than 0.05, which is statistically significant. Again, premature labor history, those with premature labor history are coded as 1, and without labor history, premature labor history are coded as 0, are compared, So compared to those women with premature labor history, those without premature labor history are less likely to get a low birth weight baby than compared to the heavier birth weight baby. And the p-value is less than 0.05, which is statistically significant. Because the beta coefficient is negative, so the probability of being in the low birth weight baby category will be less by 1.076 compared to the heavier categories, But what we want to do is we need the odds ratio, but the odds ratio is not reported here, rather the beta coefficient only. So we will follow another procedure to report this odds ratio, you know. Okay, so we'll see that. The last thing that we need to check is that the test of parallel lines, which tests the null hypothesis that the effect of each predictor variable across the categories of the outcome variable are the same. And that should be fulfilled, you know. The effect of each predictor variable across different comparisons of categories of the outcome variable should be the same. The beta coefficient or the odds ratio will be the same for a single variable across the categories of the outcome variable. So in order to accept the null hypothesis, which says the effect of predictor variables on each of the categories are the same, the p-value should be greater than 0.05. So in this case, this is 0.614. Therefore, we can say that the assumption is fulfilled for the proportional odds assumption. So we should interpret the results of this odds ordinal logistic regression result, you know. So before winding up this session, let's see the procedure how we can report the odds ratio for this ordinal logistic regression, and how we can just choose the reference category for the predictor variables. Okay, so now let's go back to the data set and then click Analyze, and now go to the general linear models. With this approach, we can get the odds ratio, and we can choose the reference groups for the predictor variables. So click on generalized linear models and again general linear models over here. So from this, the type of the model, we need to click or choose the ordinal logistic regression over here. If it is not listed over here, click over the custom icon to make this window active, and then you can choose the distribution from the listed one over here. Since the ordinal logistic regression is listed here, we need to click over there. Choose the ordinal logistic, and from click over here the response variable. So this is the response variable. We need to just take this outcome variable to the dependent variable, and we need to choose the reference category for the category of the outcome variable, you know. So we need to choose the ascending one, that is the higher. The code which is given as 3, the third category, coded as 3. But the birth weight is low birth weight, less than 2.5 kilogram, coded as 3, 0, 1, 2, 3. So the higher number or the higher categorical coding, the code 3 is taken as the reference, you know. So being, we are going to compare, finally, interpret being in the last category. That means in the third category, the probability of being in the third category versus the probability of the heavier baby birth weight, you know, 0, 1, and 2 categories. So click on the predictors, and then we need to take all these predictors from the list to this box. If factors, the categorical predictor variables will be inserted in the factors window. And here is the place where we choose the reference category for the predictor categorical variables, you know. So therefore, you need to select these predictor variables and then click on options, and you choose either ascending or descending. In this case, where we should select the descending one. That means 0, the lower score or the lower code, 0. Smokers, no is 0 and yes is 1. So we are going to make 0 as a reference, non-smokers. Premature labor history, 0, no history, 1, history of premature labor. Therefore, we are making without premature labor history as a reference group. So descending should be selected over here, and then click on continue. And then click on the model, and we need to take all these predictor variables from the list to this model, you know. So select all these predictor variables here, and then check that the main effect is there, and take to the box. The estimation technique, we are not going to do anything here, but click on statistics. This is the place where we want to choose to export or the result in the form of odds ratio. So tick the box, this include exponential parameter estimate. This is the one which will report the odds ratio, you know. So now we have finished. Click on OK finally. Click on OK. So similar results will be there. The model information, the case processing, the categorical variable coding and information, and finally maybe goodness of fit test, omnibus test, other extra tests will be there. Okay. So what we are going to see is we are interested to see the parameter estimates in order to have appropriate reference group for the predictor variables and in order to have the odds ratio, the beta coefficient to be in the form of odds ratio. Thresholds, the intercepts are similar with the previous one. And now you see the premature labor history 0 is the reference now. Without premature labor history, compared to women without premature labor history, women with premature labor history are 1.076 times more likely to have a baby within a very low birth weight group, you know. And actually we need to use the odds ratio here, 2.93. And the p-value is statistical, so the p-value is less than 0.05. So we should interpret using this odds ratio, 2.93, the one that we interpret with the previous theoretical session of this ordinal logistic regression. And again, coming to the smoking status, non-smokers coded as 0 are now reference group, you know. So compared to non-smokers, those women who smoked during pregnancy are more likely to get a low birth weight baby because the beta coefficient is positive here. And the odds ratio is 1.84, which is greater than 1. And the p-value is less than 0.028, which is less than 0.05. That is statistically significant. Okay, now again, the weight of the mother at the last menstrual period. With the unit increase in the weight of the mother, the probability of getting a low birth weight baby will decrease by 0.011 because the beta coefficient is negative. And therefore, the odds ratio will be below 1, 0.989. And we need to use this odds ratio for the interpretation, you know. And the p-value is less than 0.05. So this is the way, or the second procedure, to report the odds ratio and to choose the reference group for the predictor categorical variables in ordinal logistic regression. Okay, now again, before winding up the session, let's do this data set using STATA, you know. So I have already opened the data set using STATA. So click on statistics and then go to ordinal outcomes, and then click on ordered logistic regression. Click over here. So we need to choose the dependent variable from here. The dependent variable is birth weight cut, and by default, STATA will make you know, the one which is the lowest code as a reference category. But if we want, we need to click over the 3 dots over here, and we need to just choose the one that we want, you know. Okay, so here in the dependent variable list, we need to choose the weight of the mother because it is a continuous type of variable here, and to go there by clicking the 3 dots over here to choose the predictor categorical variables with their reference, you know. And actually we can also choose the continuous variable here by clicking the C box over here to indicate that this is continuous. Since once we have already selected, but let me remove it over here, and then let me select the continuous variable again, continuous, and then I need to select this C to indicate that this variable is continuous, and click on add to var list, and go back to the variable list, and then smoking, and I need to uncheck this one, and then the base or the reference category should be the first one, that is 0, add to var list, and go back to again the variable list, and then premature labor history, again the first should be the category, sorry, the reference, click on add to var list, and then okay. Okay, so smoking, okay. So now what we are going to do is we need to just choose whether the beta coefficient or the odds ratio should be reported by clicking over here, reporting, you know. So click on report coefficients or report odds ratio. So we need to select report odds ratio in order to get the odds ratio, you know. Okay. So I need to go back here again in order to check the continuous variable should not be labeled as a categorical variable, you know. Okay, this first stands for this one. Yeah, it is okay now. Okay. Okay, now hereafter, since we have selected the dependent variable and the independent variables, and then click on OK. So here is the similar result, you know, similar result for the previous results that we have seen in SPSS. The cut are cut 1, cut 2, cut 3 are the intercepts. So for the weight of a mother, with a unit increase the weight of the mother, the odds ratio is 0.989, similar with the output from the SPSS. Smokers are 1.83 times, and premature labor history 2.93 odds ratio. With the standard error, the Z statistics, the p-value, and the confidence interval. You know, so this is the way how we conduct an ordinal logistic regression, either using SPSS or STATA. So this is all about ordinal logistic regression. Thank you very much.